This is the scientific method video, part 2. Remember in part 1 we talked about the beginning steps of the scientific method. You used all your senses to observe your world. You came up with your problem in the form of a question. Then you did research to learn all about your topic. So you became educated so you could come up with a hypothesis, which was the educated guess. And usually it's in a if I do this, then this will happen. Now you're ready to run your experiment to either accept or reject your hypothesis. And we talked about the different types of variables. One was the independent variable. That was the variable that you change. Then we talked about the dependent variable, and this is the one that you measure, that you're going to measure and get your data for your dependent variable. Under controlled, we talked about two different kinds. You have your constants, which are those that keep the same, and we talked about a control variable in which that is the normal condition that you're going to compare the one that you changed. Just to review real quickly, the independent variable has an effect on the dependent variable. So if you want to know if adding fertilizer helps a plant grow, like in this picture here, the independent variable would be the fertilizer. The dependent variable would be the growth, or how tall the plant grew, and you would measure that and put your data each day in a chart and then create a graph. Your control would be the one on the left that got nothing, and your constants would be the same type and amount of soil, same type, size of the container, same amount of sunlight, same type of plant and size of plant. So the dependent variable is what you measure. The IV is what you change. So changes in the IV causes changes in the DV, and then you're going to measure those changes. The control variable was the one that received no difference. You didn't change anything about it. So if you look at the picture, the carrots on the left are the ones that were your control. They got nothing. They're the ones we're going to compare the ones that you did change. So the carrots on the right received the fertilizer. Now think about this. You wouldn't know that the carrots on the right, that the fertilizer helped them grow taller unless you had the control on the left to compare it to and say, oh, look, that fertilizer did work and created thicker, more hardy carrots. Every experiment's going to have the constants, and remember that I told you you can remember that the constants stand for same, because constant has an S in the middle. Those are the variables that you keep across the board the same. So in our example, the same size and type of pot, amount and kind of soil, the same amount of water daily, the same amount of light, and the same temperature. When you're thinking about your experiment, you're going to keep a list of all your materials, because remember, an experiment has to be repeatable. So if somebody wants to reproduce your experiment, they need to know exactly what you did. So you're going to, for materials, have exactly what kind of seeds. I would even write down the type of brand. Same with the plastic pots. You say 3 to 4 inch plastic pots. The labels, the potting mix. I would even go so far as to put the name brand, like Miracle-Gro. You want the water. Even I would put the measuring cup, so they knew exactly what type of measuring cup you used. The fertilizer was Miracle-Gro. I would also put, if it was liquid or granules, a clear glass jug and a plastic funnel. Be as specific as you can. Now you're going to run your experiment so you can test your hypothesis and find out if you're going to accept or reject what you guessed was going to happen. You should also repeat your experiment several times to make sure that the first results weren't just an accident. So instead of just having 2 plants, one the control and one the experimental plant, I would have several different plants. Or you could run it even longer and repeat the exact same experiment several times. If, for example, you're doing 2 different types of paper airplanes, then you need to throw those airplanes at least 10 trials. Okay? The most people will tell you 3 or 4 are good enough. But if you can do more, then your data is going to be more reliable. Every day you should record and analyze your data. So you're going to take measurements from that dependent variable and put it inside a chart each day and make notes about what you are seeing. Then at the end you can make a graph and analyze that data and say to yourself, what is my data showing me? Can I accept or do I need to reject my hypothesis? Remember, either way, it's still good scientific information. So I'm going to analyze that data and see if my hypothesis was true or false. If it was false, you still have very good scientific information. What you're going to do is you might go back and do a little more research, become more educated about why you had to reject it because of what happened, and then you're going to come up with a new hypothesis and just start the whole process again. Now, once you've analyzed your data and you can tell whether you're going to accept or reject your hypothesis, you're going to state the conclusion and communicate those results. Remember, the reason why you do an experiment is to give good scientific information to the world. There's a reason why somebody's going to want to know those results. So usually your conclusion starts with, I accept my hypothesis because my data showed that the Bounty paper towel absorbed the most water. Okay, so you're going to explain why it was true, and then you're going to tell what that means to the scientific community. So you're going to say, if I'm going to the store to buy paper towels and my choices are Brawny, Bounty, and the Walmart brand, according to my experiment, Bounty will hold the most water. So I think to get your best money's worth, you should buy Bounty. Then you're going to do a final report or a display board. In your case, you're going to do a display board on a tri-board. You do not have to write the report, but you have to have each one of the parts that we've talked about on your display board. In the scientific community, professional scientists do the exact same thing. They publish their final report, usually in a scientific journal or magazine, and they go to conferences to show all their colleagues the results of the experiments that they've been doing. Because like I said, you do an experiment to help give knowledge about your topic to the world. Here are the steps of the scientific method. So we've talked about stating the problem in the form of a question. You're going to do research and become educated. Form that if-then hypothesis. Perform the experiment. You're going to identify your IV, your DV, your constants, and your controls. You're going to specifically write out all your materials. You're also going to write the procedure down step by step. Then you're going to analyze that data and draw conclusions. And if your hypothesis is true, you're going to report those results. If it was false, you're still going to report those results, but you're going to go back and do more research and run your experiment again with your new hypothesis. You have this form. Please fill this out or take notes, because in class you're going to be asked to put these without looking in order. If you have time, go to YouTube and type in Mythbusters Scientific Method Footprints on the Moon. This is a really great experiment that they did because some people say, how could there be a footprint on the moon? And these guys explain it to you using the scientific method. It's really good. You can also go to YouTube and type in Scientific Method Mythbusters Flag on the Moon, and this is like the footstep. They do it in a vacuum and then not in a vacuum because there's so much less air in space and it's more like a vacuum. And some people say, why is the flag moving on the moon when they planted the flag if it's a vacuum? And these guys answered that question using the scientific method, and it's a really great video to watch. Make sure that you have been taking your closed notes and take a picture of them, upload them into a PDF, and save them in your Dropbox and on your Google Docs.